Okay, so this is your Pax Chiller. Okay, that compressor, okay, does not have a shaft to the impeller. That impeller has no mechanical drive at all whatsoever. The motor spins with no physical connection to the impeller which turns. How can that be? It floats on a magnetic field and spins on a magnetic field. Therefore, it doesn't need any oil because it's floating in space. It just floats in space and starts spinning. Yeah? The major components of this, of course, is the centrifugal compressor. That there, which is called the shell and tube condenser. The standard is that the temperature of the water coming from the cooling tower. So let's just have a quick look at this. That's coming from the tower, and the other one's returning, coming down into the suction via the strainer. So if you need to clean your water, right, you need to check that regularly for catching rocks and that sort of thing, right? So you've got a butterfly valve there. You shut that off. You should also have a check valve here, one-way non-return valve, and perhaps you should also have another butterfly valve so that you don't get water everywhere. Now, perhaps didn't worry about this one here because this is actually going via a heat exchanger. Now, that's a balance valve. That's not a major component. All right, so we have the water coming in at 29 and leaving at 35. That's standard. That's a standard. That condenses refrigerant. If it's working on standard pressures, the shell and tube condenser that's working on standard pressure would be condensing at, for water cooled, what would that be? You can say it. Yeah, you've just indicated with 40. Your hands, 40, that's right, okay. So 40 degrees. Now, this particular machine, because of the metering devices, see these here? This one's actually a metering device. That one there, what's that one doing? That's coming off the bottom, so that's picking up liquid off the bottom. That's coming off the top, so that's taking gas off the top, yeah? But these here meter, and they can compensate for lower head pressure. So this machine can actually operate at a lot lower than 40 degrees condensing temperature for the machine, right? That means if you can get your head pressure down, right, you're going to get a much more efficient machine. And remember, the compressor, if you have a suction pressure and you have a discharge pressure, so that'll be on the other side. If we come around here, we can see the discharge line coming off, going down into the top of the shell and tube condenser, right? If that pressure drops, the compressor doesn't have to work as hard. And if the compressor doesn't have to work as hard, its amps go down. For every percentage, if you like, of head pressure decreasing, right, and as the compression ratio decreases, which what we call lift, we call that lift on a centrifugal machine. So that's a centrifugal machine. It's a baby impeller, and these come in 1, 2, 3, 4 compressors on them. They build them here in Australia, and you actually go to the Melbourne factory and watch them being built. Okay, so as I said, 29 in from the delivery of the pump. There it is, coming around through the stat valve, entering the bottom, going in at 29, collecting the heat through the shell and tube condenser. Now, mind you as well, that this is what you call a two-pass condenser. Because if the water goes in one end and comes out the other, it's a single pass, but it's going through, turning around and coming back out. Right, does that make sense? Okay. On the top, we can tell, is the shell and tube evaporator. How do we know? Because this here stops it from sweating absorbing heat from the surrounding area and putting water all over the place. Your chilled water lines, are here. Okay. Yeah, doing a video, mate. So your chilled water lines. So what happens is your water comes in from the field, right? It's going in the bottom. And what do we mean by the field? Well, we've got things like the air handling unit over there. Yeah, we can see the supply duct coming off here, right, and it's going to the VAVs, right? These ones up here, Wes, are VAVs, yeah? Okay, so that's your field. This is only a small little plant. Once the plant's up to speed and everything's sort of chugging along, generally you're going to have a 12-degree return water and you're going to have a 6-degree supply. 12 on, 6 off. Refrigerant, 0. Okay? That means that the approach, 12 and 6, right, would be compared then, so that's pulling it down to 6, and the refrigerant might be +1, between 2, +1 and 0, which means that the approach would be anywhere between 4 for 2, 5 for 1, and 6 for 0, because 6 minus 0 would be a 6K temperature, right? So that's the approach. We can tell if the capacity is good. Now, that gives you an idea of the actual chiller, all right?